Welcome to Similarity in right triangles. Today's objective is to use geometric means to find segment lengths in right triangles and to apply similarity relationships in right triangles to solve problems. So let's examine the effects of drawing an altitude in a right triangle. So if I have a triangle and I draw an altitude, what happens is this triangle is now split into three similar triangles. And if you remember, the definition for similarity is triangles whose angles are all congruent and sides are proportional. So what happens is here we have three similar triangles now. So the triangles are triangle A, D, C is similar to triangle C, D, B, which is also similar to triangle A, C, B. So here we're going to be writing a similarity statement comparing the three triangles, but I think it's important to stop and redraw the triangles before. So we're going to start by redrawing them all. So our smallest triangle is going to be triangle SRP. Now let's make the right angle the last one for all of these. So this top part is S, this outside angle here is R, and our right angle is P. So we'll draw the second largest one next. So that's triangle TSP. So TS is our hypotenuse and P is our right angle. And the last one that we'll do is the big triangle, TRS. So this is the big one, TRS. So S is our right angle and RT is our hypotenuse. And now that we have that, it makes it easier to write our similarity statement. So our similarity statement is going to be that triangle PSR is similar to triangle PTS, which is also similar to triangle SRT. And that's our similarity statement comparing these three triangles. So another topic that we're going to explore in this section is the topic of geometric means. So we're going to be given two numbers and we're going to be finding the geometric mean of each of those numbers. When it's possible, we're going to simplify into radical form, and I'll do a little review if necessary. So for example A, our two numbers are 4 and 9. So finding the geometric mean is done by this form. So we do 4 over x is equal to x over 9. Now, if you're good with your cross multiplying, you'll see this is a good opportunity to do that. So we're going to cross multiply here to do x times x, which gives us x squared. And that's going to give us a quantity that's equal to 4 times 9. So that's 36. So then we have x squared equals 36. Now to solve this, we need to take the square root of both sides. So when we do that, we're going to get a value of x equals the square root of 36, which is just 6. Because 6 times 6 equals 36. Alright, for our next example, we'll set it up in the same format. So to find the geometric mean between 6 and 15, we do 6 over x equals x over 15. Multiply those quantities together, so we do x times x, which gives us x squared, and 6 times 15, which is going to give us 90. So this one's going to be a little more difficult than the previous one because 90 doesn't have a perfect square root. But we'll take the same steps. We'll take the square root of both sides, and we'll be left with x equals the square root of 90. Now we need to break 90 down into two products who potentially have a even square root. So we can do 9 and 10, because 9 times 10 gives us 90. Now, the square root of 9 we should be able to break down, and that's going to give us x equals 3 times the square root of 10. Now, that's our final answer because we can't break down 10 into anything that has a perfect square root, because factors of 10 would be 10 and 1 and 5 and 2, and neither one of those can be broken down any further. So our final answer is going to be x equals the square root of 10 times 3. So now we're going to learn something that I refer to as the bowling ball trick, and this is going to be a simpler way for us to identify the relationship between the sides of a triangle that are created by an altitude coming in. And like I showed you at the beginning of the video, when you bring that altitude in, it creates three similar triangles, and we can find different measurements on the triangle using this trick. So when you're given a triangle that's drawn in this fashion, what you can do is you can draw two bowling pins. So basically they're just ovals. So here is the first one. And you want to include the letters B, Y, and C into that bowling pin. And here's your second bowling pin. Your second bowling pin is going to include the A, the C, and the X. Now the bowling ball is in the middle of it. So the bowling ball, I'll use a different color here. So the bowling ball includes the X, the H, and the C. Now I know it seems like I just circled things arbitrarily, but what happens is we can use a certain formula now to find any of these measurements. So let's start with bowling pin number 1. So to find any of the measurements, whether it be B, Y, or C, we can set up this ratio. So we can say that B is proportional to Y the same way that C is proportional to B. So we can say that B is proportional to Y the same way that C is proportional to B. So that's how we find any of the measurements of that first bowling pin. So for the second one, same idea. We can say that A is proportional to X the same way that C is proportional to A. So we start all the way outside. So we say A is proportional to X the same way that C is proportional to A. And finally, for the bowling ball, we always start off with the altitude. And we say that H is proportional to X the same way that Y is proportional to H. So that's how we use our bowling pin and bowling ball trick to help us find these lengths. And if you notice that in each of these proportions, there is some geometric mean element happening. So what most textbooks tell you is they just give you the formula afterwards. So they just say, okay, B squared equals CY. They say that A squared equals CX, and that H squared equals XY. Now, if you want to memorize it that way, that's fine too, but I find it easier to look at your diagram, draw your bowling pins, and then use the proportions to cross multiply and divide. Alright, so let's use our bowling pin and bowling ball to help us find some measurements here. So let's start off by finding X. So here's my bowling ball. I have X, 2, and 10. So to find X, I can set up this proportion. I can say that X is proportional to 2 the same way that 10 is proportional to x. So now that we have a proportion, we can cross multiply here. So we're going to have our x squared equal to 20. So from here we can take the square root of both sides, and we have x equals the square root of 20, which we have to break down into the square root of 4 times the square root of 5. So that's going to be 2 root 5. Okay, so we found x. Let's find y. So for y, we want to draw our bowling pin again. So we're going to start off with the y. We're going to draw here to the 10, and then we're going to include this c. Now the c is out here, but what the c is the length of this whole segment. So that whole segment is 2 plus 10, which is 12. So our c is 12. So now to write our proportion, we start with our y. We say y is proportional to 10, the same way that 12 is proportional to y. So remember, we go y, 10, 12, back to y. And then from there we can do our cross multiplication. So we do y times y gives us y squared, and then 12 times 10 gives us 120. Then from there we take the square root of both sides. So we have y equals the square root of 120. So for the square root of 120, we're going to break this down into the square root of 4 multiplied by the square root of 30. Because 4 times 30 would give us 120. We can break the square root of 4 down to be 2. And then we have a length of 2 times the square root of 30. So to find z, let me just erase a little bit of what we have here. Okay. Alright, so to find z, we're going to do the same bowling pin. So we already have our c for us, which is at 12, so we'll go z is proportional to 2, the same way that 12 is proportional to z. So we go z is proportional to 2, the same way that 12 is proportional to z. And then from there we can do our cross multiplication. So we have z squared equals 24. We take the square root of both sides, and we have z equals the square root of 24. So ask ourselves, what two factors of 24 can have a possible square root? So we have the square root of 4 times the square root of 6, which would be good for us. So we'll write that. And then the square root of 4 is just 2. And then we have 6. And there's our final answer. So that's how we use our bowling pins and our bowling ball to help us find the side lengths of a triangle that is cut into different triangles using its altitude. Alright, so let's use our knowledge of the bowling ball and bowling pin to help us find the height of big text here. So they give us a few different measurements here. So they give us the height of the individual here who's 5 feet tall, and they tell us the distance from his eyesight to what looks like his legs, effectively. So one thing that I'm going to do is I'm going to change this into inches. So I'm going to change 5 feet into 60 inches, and then I'm going to change 15 feet 3 inches into 183 inches. Okay. But I can use my bowling ball and bowling pin here to figure out the height. So what I want to find is this length right here. which is effectively is my C. So we can do this a few different ways. So one way we could do it is we could find this length here by using the Pythagorean theorem. So we could do 183 squared plus 60 squared equals x squared, solve for x, and then we can do the bowling pin using these two segments here. But what's actually going to be easier is just to use the bowling ball. So if you can imagine it, here's our first value here. Our second value is going to be this 5 here. And then we have some mystery value here, the y. So the y would represent this side length right here. So let's draw that out. So that's going to be 183 over 60 is going to be equal to y back over 183. So let's cross multiply to figure out what's happening here. So we're going to do 60y is equal to 183 times 183, which is going to be 33,489. And then we'll divide both sides by 60. And we have y equals 3,489 divided by 60, which is going to give us 564.15 inches. So what I'm going to do is I'm going to change that now. That's in inches. Let's change that back to feet. So we'll just divide that by 12. And it's going to give us y equals about 47 feet. Now careful here, because 47 isn't the answer. 47 is just the distance y here. So this is 47. So what we need to do to find Big Tex's actual height is to add the 47 to the 5. So the final height is going to be 47 plus the 5, so it's going to be 52 feet. So I did some rounding here at this step because we're rounding it to the nearest foot. And that's how we use our bowling ball and bowling pin to help us find different heights. That's going to be the end of our video for today. I hope that was helpful. Thank you and take care.